Section 3.3 is on the derivatives of polynomials and the derivative of e to the x. We have the power rule as the main rule for this section, and we're going to practice that one. We also have the constant multiple rule, so if you take the derivative of a constant times a function, you could remove the constant, so you could multiply the constant times the derivative of the function. We have the sum rule and the difference rule. And then one of our favorites is the derivative of e to the x. It remains unchanged when you take the derivative. So we're going to see that in some examples. Calculate the derivative of the following. In number 1, I've been given notation f of x. So I'm going to write my derivative as f prime of x. And I'm going to use the power rule. So the power rule says I'm going to take the power on x and multiply it against the coefficient. So 3 times 4 is 12, and then I'm going to reduce the power by 1. I'll do that to the next term, so that's minus 14x. For number 2, I have the notation as y equals, and the variable is t. Therefore, I'm going to write dy dt. So I'll use this Leibniz notation, and power rule on the first term gives me 2t to the third minus the derivative of e to the t is just e to the t. Number 3, the square root of x is the same as x to the 1/2, so you may choose to rewrite this as x to the 1/2, and you apply the power rule to this function. So since its notation is g of x, I will write g prime of x and bring the 1/2 down in front and reduce that power by 1, which takes it to negative half. Please do not leave negative exponents in your answers, so rewrite your answer as 1 over 2 root x. This one will come up a lot, so try to remember this. The derivative of the square root of x is 1 over 2 root x. Number 4, this is written as a product, and we do not officially have the rule for taking the derivative of a product. So I'm going to multiply this out first. It is 2x squared. I have a plus 8 and a minus 3, so that's a plus 5x minus 12. Now I'm ready to take the derivative. Let's write the notation as dy dx, and I get 4x plus 5. Number 5 is like number 4. I'm faced with a quotient here, but I haven't officially gotten the quotient rule. I wouldn't use the quotient rule on this one anyway, because I can divide the polynomial in the numerator by the monomial in the denominator very easily. So I'm going to write this as 2x squared minus 5 and take the derivative. Remember that the derivative of a constant is just 0, so you've seen that on a couple of terms here. Number 6, this is a product again, and what you might want to do is change the square root of x to x to the 1/2, and then the term that has 3 over x, you might want to write that as 3 times x to the negative 1. So I'll show you what that looks like. That would be x to the 1/2 parentheses x plus 3x to the negative 1. And now I'm going to distribute x to the 1/2. And when I do, my exponent rules say I'm going to add the exponents. So x to the 1/2 times x is x to the 3/2. And then x to the 1/2 times 3x to the negative 1 is 3x to the negative 1/2. And now I'm ready to take the derivative. Let's denote it with f prime of x. We're going to bring the 3/2 down in front, and when I reduce that power by 1, it becomes a 1/2 power. And then bring that exponent down in front, I get minus 3/2 and x to the negative 3/2. If I rewrite this answer, I can write 3/2 square root of x minus 3 over 2 x root x. So that's so I do not have any negative exponents, and I also do not have a fractional exponent. Okay, I want to touch upon these types of questions every opportunity I can. They're asking me to evaluate a limit. This is a very special kind of limit. Notice how the limit is as h goes to 0, and the denominator we have an h. So that should signal to you that we're looking at the setup of the definition of derivative in this math problem. The definition of derivative is this. So what I'm going to do is I'm going to correspond the parts of the fraction to what I see in the definition of derivative. In the numerator of the definition of derivative, I have this piece right here, where you substitute x plus h into the function. Well, I contend that it corresponds to this part of my math problem. I can see a 1 plus h in two places there. So that's where the original x would be in the function that I'm being presented with. So I'm going to set up the function first. The function starts with a 4, and notice how the 1 plus h quantity squared happens after that. So that's where there's an x, an input location, squared. Copy the plus, and then there's a 2 over the square root of x. I picked up the function that they're talking about by looking at where the 1 plus h was in that math problem. Notice that it's 1 plus h. So the 1 is like the x location of where we are when we're taking this derivative. So I'm going to write at x equals 1. And if you just want to check your function to make sure you're correct, you can take the value x equals 1 and substitute it back in. So I'm going to evaluate f of 1, and I'll get 4 times 1 squared plus 2 over the square root of 1, which is 4 plus 2, which is 6. And that matches this number right here. Look back at the definition of derivative. You want f of x there after you subtract. I know that I have the right function now. All I have to do is take the derivative of the function. I'm going to rewrite the function first. So I have 4x squared, and then the 2 over root x can be written as 2 times x to the negative 1/2. Now I can employ the power rule. So the derivative of f is 8x minus x to the negative 3/2. And now I will find f prime of 1. So that's 8 times 1 minus 1 to the negative 3/2, which is 8 minus 1, or 7. In number 8, I'm noticing this is a limit as h approaches 0, and I have h in the denominator. So this math problem is taking on the look of the definition of derivative. I'm noticing in the front part that 2 plus h is being used in two places. So I'm going to suppose that my function is e to the x minus x. And because the 2 is with 2 plus h, I believe they're taking the derivative at x equals 2. So I'm going to check if I'm doing this right, and I'm going to evaluate f of 2 in my function. I get e squared minus 2, and that does match the back end here. So I think my function is good. And now I'll take the derivative of f. That gets me e to the x minus 1, and then I'll evaluate f prime of 2. So that's e squared minus 1. Please practice these problems when they're assigned, because they're now using them on the AP exam.